Hello everyone. In last lecture in detail we discussed why we should use staggered grid over collocated grid, and we have already discussed that in Mach algorithm we use primitive variable approach and staggered grid. So, today using this Mach algorithm we will discretize the unsteady two dimensional Navier-Stokes equations and we will write the discretized equation. Finally, we will discuss about the algorithm to solve this governing equations. So, let us write the governing equations. So, 2D unsteady Navier-Stokes equations. Okay, so, we are going to write for incompressible flows. So, density is constant. So, you can write rho del u by del t plus u del u by del x. So, we are writing in non conservative form v del u by del y is equal to minus del p by del x plus mu del 2 u by del x square plus del 2 u by del y square. So, this is your x momentum equation and this is your temporal term. These two terms are convective terms, this is your pressure gradient term and this is your diffusion terms, and mu is your dynamic viscosity, rho is your density of the fluid. Similarly, you can write the y momentum equation rho del b by del t plus u del b by del x plus v del b by del y is equal to minus del p by del y plus mu del 2 v by del x square plus del 2 v by del y square. Okay. And we have also the continuity equation del u by del x plus del b by del y is equal to 0. So, you can see that with the known fluid where density and viscosity are known, then you have three unknowns u, v and p, and we have three equations. Now, we will use staggered grid. So, in staggered grid we will solve P at the cell center. So, this is your cell for P, this is your main cell, and we will solve the velocities in staggered manner. So, u will solve in this phase. So, it is phase center. So, it is u p, and we will solve the v at this phase center. So, this is your v p. Okay. So, obviously, you can see that you will have here v s, okay, and here you will have u e, sorry, u w. So, here you will have u w, and similarly here you will have u e, and here you will have v n. So, as I discussed in last class that p denotes I j, okay, indices I j, e denotes I plus 1 j, west w denotes I minus 1 j, north n denotes I j plus 1, and south s I j minus 1. So, for each variable you can see that for pressure P, velocity u and velocity v. Okay. So, we use this indices I j for P, I plus 1 j for E, I minus 1 j for W, I j plus 1 for N, and I j minus 1 for S. Okay. So, now discretize these equations. First, let us discretize the temporal term. So, you have temporal term Okay. First we will derive for the x momentum equation, then rho del u by del t. So, if you use forward time and central space, because we discussed that in Mach algorithm we will use forward time and central space. Okay. So, rho del u by del t, you can write rho u n plus 1 minus u n divided by delta t. So, it is forward time. And convection terms, so that is your rho u del u by del x plus v del u by del y. Okay. So, we will denote it as delta c u. Okay. So, convection terms delta c u. So, that you can write. So, you can see, so first term, so u del u by del x, okay, u del u by del x. So, for the which control volume you are which, so u cell is this one. Okay. So, this is your u cell. So, now we are discretizing these u momentum equations. Okay. So, obviously you can see that you will have here P E, okay, and here you will have P N, okay, and V cell is this one. This one is your V cell. Okay. So, now we can write u del u by del x, okay, for this u control volume. So, for this u control volume, what you can write? You can write u p, okay, and del u by del x. So, del u by del x we need to use central difference. So, you can write u e minus u w divided by delta x. Okay. So, if all are having this delta x uniform grid, if you have, then you can write delta x, and this is your delta y. And for the second one, now V at this point, okay, in the center for this UP cell, V is not available. So, V you have to interpolate. So, from where you will interpolate? So, you can see here you have V, okay. So, this is your VP. So, this is your VE, okay. This is your VAC, right, southeast, V southeast. So, V you interpolate at this center for the UP cell as VP plus VE plus VS plus VAC divided by 4. So, now we are interpolating V at the P as VP plus VE plus VAC plus Vs divided by 4. So, this is just interpolation, okay, because we are finding the value of V at the center of this UP cell, okay, at the UP cell here. So, obviously, this from this 4 B cell we are just interpolating this value at center for UP cell, and now you have del u by del y. So, now del u by del y you can see easily you can find. So, this is your u north, and so you can write, so del u by del y, okay. So, del u by del y, so north, so you can write u n minus u s divided by 2 delta y, okay. So, u s will be US will be somewhere here, another cell if you take. So, it will be US somewhere here, it will be there. So, you can write UN minus US divided by 2 delta y. So, obviously, this is second order accurate. So, you can see the convection term we have discretized for the x momentum equation using central difference method. Okay. So, the order of accuracy of this discretization is delta x square and delta y square. So, order of accuracy is delta x square and delta y square. Okay. And this temporal term order of accuracy order of delta t. Okay. Now, let us discretize the pressure gradient term. So, pressure gradient term. Okay. So, now let us write the pressure gradient term minus del p by del x. So, this minus del p by del x we need to find for the UP cell, right, because we are solving the x momentum equation, and for that cell we need to know the pressure gradient minus del p by del x. So, if you see this cell UP cell, so this is your UP cell. So, this UP cell if you see, so pressure gradient in the x directions you can easily write P minus Pp divided by delta x, right. So, this you can write as minus Pe minus Pp divided by delta x. Okay. So, this is also central difference you can see. So, order of delta x square, and now we have diffusion term. Okay. So, diffusion terms we will denote as delta du. So, we have mu del 2 u by del x square plus del 2 u by del y square. Okay. So, that you can write as, now you see the UP cell. Okay. So, in UP cell now you see del 2 u by del x square. So, if you use the second order central difference discretization, then usually you can write at UE minus twice UP plus UW divided by delta x square, right. So, we will write as UE minus twice UP plus UW divided by delta x square. Okay. So, central difference we are using for the second derivative. Okay. And del 2 u by del y square. So, del 2 u by del y square you can see UN minus twice UP plus US divided by delta y square. So, you can write as UN minus twice UP plus US divided by delta y square. Okay. So, you can see the order of accuracy is delta x square delta y square. Okay. So, let us now put all together in a discretized form for the x momentum equation. So, we can write as rho u p n plus 1 minus u p n divided by delta t. Okay. Convection term whatever way we have discretized, that in short form we are writing delta c u n is equal to minus P e n plus 1 minus P p n plus 1 divided by delta x plus delta d u n. Okay. And similarly, you can write for v velocity v p n plus 1. So, similarly, you can derive all these terms and write it for the v momentum equation plus delta c v n is equal to minus p n n plus 1 minus p s n plus 1 divided by delta y plus delta d v n. Okay. So, let us write the equation number. Okay. So, this equation number 1 and this equation number 2. Okay. So, these are the discretized form of the x and y momentum equations, okay, and we have used forward time and central space discretization. So, overall order of accuracy is delta t, delta x square, delta y square. Now, if you see this governing equation, in the left hand side in the temporal term you have one unknown u p n plus 1 and all other velocities are known. But if you the pressure term, so pressure term you have to take at n plus 1, but at n plus 1 pressure is unknown. Okay. So, we have to now simplify it in some way. So, what we will do now, we will calculate some provisional velocity u tilde assuming the pressure from the previous time level n. Okay. N plus 1 is the current time level and n is the previous time level. So, we will find some provisional velocity or predicted velocity using the pressure value at previous time level n. So, if you write the equation, so we will write rho. So, now as we do not know the pressure at n plus 1, we will use pressure at n and we will get some provisional velocity u tilde minus u p n divided by delta t plus delta c u n is equal to minus. So, pressure now we are taking from the nth time level, that is why we are writing this tilde velocity, okay, which is your provisional or predicted velocity from the previous time level pressure. Okay. So, plus delta d u n, and for v velocity you can write v p tilde minus v p n divided by delta t plus delta c v n is equal to minus p n at time level n minus p s at time level n divided by delta y plus delta d v n. So, these equations number let us give as 3 and 4. Okay. So, you can see that equations 1 and 2 we need to solve, but there are too many unknowns because you have u n plus 1, v n plus 1 we need to solve for, and pressure is also unknown at n plus 1. So, what we did, we assumed the pressure from the previous time level and we are solving these equations. So, obviously, we will get some provisional velocity and that we are denoting as u tilde and v tilde. So, now you subtract equation 3 and 4 from equation 1 and 2. So, now subtract equations 3 and 4, okay, from equations 1 and 2 respectively. Okay. So, what you will get, you see. So, obviously, from the first term you will get u p n plus 1 minus u p tilde divided by delta t. Okay. The convection terms are same. So, this will cancel out, then you will have only pressure term in the right hand side. So, you can see that you will have P e n plus 1 minus P e n and minus P p n plus 1 minus P p n divided by delta x, and you see the diffusion term, okay, diffusion terms are same. So, this will cancel out. So, we will get this equation, and that we can write the difference between P n plus 1 minus P n as P p prime. So, you can write minus P e prime minus P p prime, okay, divided by delta x. Okay. And so, you can write now u p n plus 1, you can write as u p n plus 1 is equal to, so u p tilde, okay, minus p e delta t by rho delta x p e prime minus p p prime. Okay. And similarly, if you subtract equation 4 from equation 2, you are going to get rho v p n plus 1 minus v tilde p divided by delta t is equal to minus p n n plus 1 minus p p n minus p p n plus 1 minus p p n divided by delta y, and this you can write in terms of p n prime. So, this will be n. So, you will get p n prime minus p p prime divided by delta y, and you can write v p n plus 1 is equal to v p tilde minus delta t by rho delta y p n prime minus p p prime. Okay. Now, let us write the equation number. So, this equation u p n plus 1, let us write equation 5, and this v p n plus 1 as equation 6. Okay. So, after subtracting, we got some relation between the provisional velocity and the corrected velocity u p n plus 1 in terms of pressure correction. Okay. So, now p p prime we have written as p p prime, okay, that we have written as p p n plus 1 minus p p n. Okay. So, the difference of pressure at n plus 1 and n, we are telling that this is known as pressure correction. Pressure correction. Okay. So, p p prime. So, in terms of p p prime we have written. So, now you can see that equation 5 and 6, okay, equation 5 and 6, if u p delta and b p tilde you can solve from equation 3 and 4. Okay. So, you can get, once you know the u p delta and b p tilde, then if you know the pressure correction, then you will be able to get the u p and v p at n plus 1 time level. Okay. So, now we have to find what is the p p prime, because that is the pressure correction is unknown. Okay. So, now as pressure correction is unknown and there is no separate pressure equation, we need to derive it from the continuity equation. Now, we will satisfy the continuity equation in the main cell of pressure P, and we will derive the equation for pressure correction. So, here let us write that u tilde P and v tilde P are predicted or provisional velocity. Provisional velocity. So, now we will start from the continuity equation. So, for 2 dimensional incompressible flow, continuity equation is del u by del x plus del v by del y is equal to 0, and this will satisfy at the main cell of pressure P. So, if you see the main cell, so this is your main cell, where this is the cell center where P p is there, and this is your P east, this is your P west, this is your P north, and this is your P south. Okay. and velocities. So, u velocity you have here. So, this is your u up, okay. This is your u w, and you have v velocity v p, and this is your v south. Okay. So, now let us write the continuity equation. Del u by del x plus del v by del y is equal to 0. So, now you discretize u p n plus 1 minus u w n plus 1 divided by delta x. So, del u by del x, okay, del u by del x we are finding at the cell center of pressure P. So, obviously about this point if you write, then obviously you can write u p n plus 1 minus u w n plus 1 divided by the distance delta x. So, this is your delta x and this is your delta y. Okay. Now, del v by del y, similarly about this cell center, if you find the derivative del v by del y, it will be v p n plus 1 minus v s n plus 1 divided by delta y is equal to 0. So, it will be v p n plus 1 minus v s n plus 1 divided by delta y is equal to 0. And what is the order of accuracy of this discretization? Obviously, delta x square delta y square, because we use central difference. Now, the relation what we derived for u and v, equation 5 and 6, we will substitute there, because u p n plus 1, okay, this is the relation, v p n plus 1, this is the relation. So, u p n plus 1, what is the relation? U p tilde minus delta t by rho delta x p e prime minus p p prime. Similarly, you can write u w n plus 1. So, for the velocity u w, similarly you can write u w tilde minus delta t by rho delta x, and what is the pressure gradient for this term? It will be p p minus p w. So, p p prime minus p w prime. Similarly, for v you can write v p n plus 1, already we have derived it, v p tilde minus delta t by rho delta y, and pressure gradient is p n prime minus p p prime. And similarly, you can write for v s n plus 1 as v s tilde minus delta t by rho delta y p. So, the pressure difference for this cell will be p p prime minus p s prime. Okay. So, now these you substitute in the discretized continuity equation. So, if you substitute it and rearrange it, you are going to get u p tilde minus u w tilde divided by delta x after rearranging. Okay. You will get v p tilde minus v s tilde divided by delta y minus delta t by rho delta x is there, and another delta x we are dividing. Okay. So, it will be delta x square, okay, and it will be p e prime minus p p prime minus p p prime minus p w prime, okay, and you will get again minus delta t by rho delta y square, and you will get p n prime minus p p prime minus p p prime minus p s prime equal to 0. Okay. So, after substituting and rearranging, you will get this equation. Now, further let us rearrange it. So, you can write it as, so the pressure term, okay, pressure term let us write in the left hand side. So, if you write this, you see P E minus p p prime and minus p p prime. So, it will be minus 2 p p prime and this will become plus p w prime. So, if you write this, so it will be p e prime minus twice p p prime plus p w prime divided by delta x square, plus from here you will get p n prime minus twice p p prime minus p s prime divided by delta y square, and other terms you take in the right hand side. So, you will get rho by delta x, sorry, rho by delta t. So, you will get rho by delta t u p tilde minus u w tilde by delta x plus v p tilde minus v s tilde divided by delta y. So, can you recognize left hand side and right hand side? So, left hand side if you see, it is the discretization of the grad square p prime, okay, because grad square p prime is del 2 p prime by del x square plus del 2 p prime by del y square. Now, del 2 p prime by del x square, if you use central difference, you are going to get this you will get this discretization p prime minus 2 p prime plus p w prime by delta x square. Similarly, del 2 t by del y square, if you discretize it, you will get p n prime minus twice p p prime plus p s prime divided by delta y square. Okay. So, this is nothing but grad square p prime. Okay. And right hand side you see, this is nothing but the divergence of u tilde. Okay. So, that means whatever provisional velocity you are getting, for that if you satisfy the continuity equation, then you will get rho by delta t divergence of u tilde. Okay. So, initially provisional velocity, it will not satisfy divergence of u will not be 0, okay, but at convergence, okay, at convergence divergence of u prime will tend to 0. So, this will satisfy the continuity equation u tilde. Okay. So, this is the equation for the pressure. So, it is known as pressure Poisson equation. Okay. So, this is known as pressure correction equation, sorry, this is known as pressure. So, this is known as pressure correction equation, and this is your pressure Poisson equation. Okay. And you can see, so you can see that this equation is difficult to solve because you have a pentadiagonal matrix. So, Mach algorithm suggests that you assume the corrections of neighboring terms as 0. Okay. So, in the Mach algorithm suggests that the pressure correction in the neighboring cells as 0. So, this is the assumption. So, you have p e prime minus twice p p prime plus p w prime by delta x square plus p n prime minus twice p p prime minus p s prime divided by delta y square is equal to rho by delta t u p tilde minus u w tilde divided by delta x plus v p tilde minus v s tilde divided by delta y. Okay. It is assumed that the pressure correction in neighboring cell are 0. Okay. So, you can see, so if you assume this, so this will be 0, this will be 0, this will be 0 and this will be 0. Okay. So, essentially you will get p p prime is equal to minus u p tilde minus u w tilde divided by delta x plus v p tilde minus v s tilde divided by delta y, and you will have 2 delta t by rho 1 by delta x square 1 by delta x square plus 1 by delta y square. So, simplifying this pressure correction equation, what was pressure Poisson equation, now you have written a formula to find the pressure correction P prime, okay, because only one is unknown P prime. So, P p prime. So, this is a formula. Okay. So, P p prime you are finding from the known delta T density, then delta x, delta y, and the divergence of u tilde, and you can see that at convergence divergence of u tilde will be tend to 0. That means that time pressure correction also will be 0, and if pressure correction is 0, so P n plus 1 will be P n. Okay. So, now this equation, okay, you can actually use some over relaxation factor for further accelerating the solution. So, in order to accelerate the calculation, the above equation is modified as, so we will use some over relaxation factor minus w naught u p tilde minus u w tilde divided by delta x plus v p tilde minus v s tilde divided by delta y divided by 2 delta t by rho 1 by delta x square 1 by delta x square plus 1 by delta y square. Okay. So, omega naught you need to find by trial and error method, but mostly you can use it between 1.4 to 1.8. Okay. You can use around 1.4 or 1.5 to 1.8. So, this is your over relaxation factor. Okay. So, this equation now let us give as numbered. So, earlier we used 1, 2, 3, 4, 5, 6. Okay. So, this you can write as 7. Okay. So, you see in this equation, okay, in this equation we are telling that if divergence of u tilde will be tend to 0 at convergence. Okay. So, that means this criteria you can use as the convergence criteria for the inner loop. Okay. For the inner loop you can use this as convergence criteria. So, now you can see that once you solve the u tilde b tilde, then that you can use in to find the p p prime, because u tilde, if you v tilde you know, then you can find the p p prime, and once the p prime is known, now you can update the velocities as u p n plus 1 is equal to u p tilde minus delta t by rho delta x p e prime minus p p prime, okay, and v p n plus 1 as v p n v p tilde minus delta t by rho delta y p n prime minus p p prime. So, this way you can solve to find the updated velocities u n plus 1 and v n plus 1, and if you want to find the pressure, so pressure also you can find, you see p n plus 1 is equal to p n plus p prime. Okay. So, this is the equation, right, p n plus 1. So, p, if you write cell p, so it will be p p n plus 1 is equal to p p n plus Pp prime. So, at convergence Pp prime will be 0. So, Pp n plus 1 is equal to Pp n. So, obviously, whatever u tilde I will get, that will be u n plus 1. Okay. So, now let us write the algorithm. Okay. So, whatever we discussed and discretize these equations, how we will solve using Mach algorithm. So, the algorithm will be like this. Okay. First you initialize, okay, u n, b n, p n, okay, and also obviously you need to generate the grid and you have to also initialize this value, okay, at t is equal to 0. Okay. So, time t is equal to 0, you need to initialize the values, then you predict u tilde and v tilde. Okay. So, what are the governing equations you have already derived? So, rho u p tilde minus u p n divided by delta t plus delta c u n is equal to minus p e n minus p p n divided by delta x plus delta d u n, and for v, v p tilde minus v p n divided by delta t plus delta c v n is equal to minus p n n minus p p n divided by delta y plus delta d v n. Okay. So, if you solve these equations, you are going to get u tilde and v tilde, which are the provisional velocities. Once you know the provisional velocities, now update the boundary conditions. Okay. If it is Dirichlet type boundary conditions, it will not matter, but if you have some Neumann type boundary condition, it is better to update the boundary values. Then you solve for the pressure correction. Okay. So, that is the formula. So, calculate. So, you need to solve, you need to calculate only, okay, because calculate p prime field. Okay. From where? So, you have the equation p p prime is equal to minus omega naught is your over relaxation factor, u p tilde minus u w tilde divided by delta x plus v p tilde minus v s tilde divided by delta y divided by two delta t by rho 1 by delta x square plus 1 by delta y square. Okay. So, now once you know the p p prime, now you can update the velocities. Okay. So, in next step you update u tilde and v tilde to u n plus 1 and v n plus 1. Okay. So, you know u p n plus 1 is u p tilde minus delta t by rho delta x p e prime minus p p prime, and u p n plus 1 is equal to, sorry, v p n plus 1 is equal to v p tilde minus delta t by rho delta y p n prime minus p p prime. So, you know p prime. So, and also u tilde already you have solved. So, you update the velocities at n plus 1, and also if you want to find p n plus 1, that also you can do p n plus p prime, but although this you are p p n plus, so this is p prime. Okay. So, p n plus 1 p is equal to p p n plus p prime. Okay. So, this once you know, you again update the boundary values, update the boundary values. Okay. Now, check for the convergence, okay, for the inner loop. So, check, okay, divergence of u tilde, and this is a vector, okay, n plus 1 L2 less than epsilon, where epsilon is a pre assigned some convergence criteria, maybe 10 to the power minus 6 or minus 4. Okay. So, that you check. Okay. Okay. So, if converged go to next time step, okay, next time step, and assign u n p is equal to u p n plus 1. So, this is now as initial guess whatever you have used at t is equal to 0. Now, for the next time step, this is the value you will use, okay, b p n plus 1 and p p n as p p n plus 1. Okay. So, if converge, go to the next time step and repeat, okay, next time step and repeat the. So, if converged, go to next time step and you put it and repeat the algorithm. If not, so otherwise repeat 2 to 6, okay, repeat 2 to 6. So, you do not update the values, you repeat 2 to 6 for convergence or till convergence, till convergence. So, you can see, so this is the algorithm you have to follow to solve these equations. So, first you solve the provisional velocities. Once provisional velocities you know, you can solve for the pressure correction equation. Once you know the pressure correction equation, you can solve for the updated, you can update the velocities u n plus 1 and b n plus 1, and if check for the convergence, if it is converged, then you go to the next time step and update u n as u n plus 1, b n as b n plus 1 and p n as p n plus 1 and repeat the algorithm. And if not, then you have to satisfy divergence of u tilde. Okay. So, that you have to repeat 2 to 6. Now, quickly we will discuss about the boundary conditions, because you have seen that for this Mach algorithm you have no slip boundary conditions, let us say on this right wall. Okay. So, no slip condition you have. Now, for u velocity if you see, okay, u velocity if you have two cells here, where do you solve for u velocity? So, these are pressure, right, for pressure you have these values and you have v velocities here. Okay. So, if v velocity is here, now how we will find or apply the boundary condition. So, obviously V p at boundary V b as 0. Okay. So, now you take a fictitious cell here. Okay. So, you use some fictitious cell and this is your fictitious cell value. Let us say this is V prime 1, okay, and let us say this is your V 1. Then you see, so if V b is 0, okay, so if V b is 0, then you can write V 1 plus V 1 prime divided by 2 is equal to 0. So, that means V 1 prime will be minus V 1. Okay. So, when you are solving for this V velocity cell, okay, you need the value from the neighbor, and this neighbor value is V 1 prime, and V 1 prime is your some ghost cell value. So, V 1 prime you can assign from the boundary condition if it is no slip condition as V 1 prime as minus V 1, and because at the boundary V b is 0. So, when you are solving for V 1 you will get the V 1 prime. Similarly, if you have a bottom boundary, okay, so now you have the velocities, u velocities So, this is your P, okay, and you have u velocity here. So, you have u velocity here. Now, you have u b is 0, that is your boundary condition, and you need to now let us say this is your u 1, you use some fictitious cell or ghost cell, okay, where you have u 1 prime. Okay. So, this is fictitious, you do not need to generate the mesh for it. So, just you need the array for this. So, for this now to satisfy the no slip condition at the wall u b is equal to 0. So, obviously u 1 plus u 1 prime divided by 2 will be 0 and u 1 prime will be minus u 1. Okay. So, when you are solving for this cell, okay, for u velocity cell, you need the neighbor values of u 1 prime, and that u 1 prime you can assign as minus u 1. For v velocity you do not need, okay, because v velocity exactly satisfies this, because v velocity you are solving here. Okay. So, this is your v 1 and this is your v b is equal to 0. So, obviously v 1 when you will solve for this v 1 cell, then obviously you can use v b is equal to 0. Okay. So, similarly when you are solving for u, so when you are solving for this v, so you see u where you are solving, here you are solving u here and u here. So, when you are solving for u here, okay, let us say this is your u 1. So, if you are solving for u 1 and this is your u b is equal to 0 because no slip condition, then when you are solving for this cell of u 1, you need the value of u b only. Okay. So, u b directly you will get, but when you are solving for v, okay, you need the value from v 1 prime, okay, and that is unknown. So, that we are using satisfying the no slip condition at the boundary. So, v b is equal to 0 and v 1 prime is equal to minus v 1. Similarly, when you are solving for top and bottom boundary, so this will be when you are solving for this velocity, you need to know the value at u 1 prime, which is your fictitious point, and that you can assign u 1 prime is equal to minus u 1. Okay. So, accordingly you can derive for other boundary conditions to solve these discretized Navier-Stokes equations. So, in today's lecture, so we started with the Navier-Stokes equations, then we use forward time and central space method to discretize the u and v momentum equations. So, as pressure at n plus 1 is unknown, so we solved for the provisional or predicted velocity u tilde and v tilde, taking the pressure at previous time level n. So, when we subtracted this equation u n plus 1 and u tilde, we got the values u n plus 1 in terms of u tilde and the pressure correction, okay, where p n plus 1 is equal to p n plus p prime and p prime known as pressure correction. So, to update these values u tilde is known, but pressure correction is unknown. So, we used continuity equation to get the pressure correction equation. So, we got a pressure Poisson equation. So, in Mach algorithm it simplifies as assuming the neighbor pressure correction velocity as 0. So, we got a formula to find the p prime in terms of the divergence of u tilde, and we have the density rho delta t and delta x and delta y. Now, at convergence divergence of u tilde will be 0 because it will satisfy the continuity equation. So, now once you find the pressure correction, that you can use to find the corrected velocities u n plus 1 and v n plus 1. So, and also we discuss the solution algorithm, and at last we discuss about the boundary conditions for this staggered grid. Thank you.